Hello, this is lesson 4, video 2 for Unit 2 Thermochemistry in Chemistry 2. The last video we came up with this summation equation for heat of formation problems. So we're going to look at two example problems and they are listed here. So you're going to need your purple packet ready to go. And we said that we were going to use a summation equation, which was the sum of the moles times the chart value for products minus the same for reactions. So if you remember, reactants are on the left of the arrow, products are on the right. So we're going to take the sum of these, each times its chart value. So we have to look up the values for each one of these on the chart. Make sure that you have the right state of matter. We have 1 mole of each of these. So if you want to pause the video, and then you can look up the values, and then you can restart it and see if you got them correct. So for HNO3, I got negative 173.22. For NaOH, negative 416.89. For NaNO3, negative 466.68. And for H2O, liquid, negative 285.83. So now that we have those values down, now we have to look, we have coefficients of 1 in front of everything. So products minus reactants, and it's very easy to make mistakes writing these down, so use groupings. So I have 1 NaNO3, so 1 times negative 466.68 plus 1 H2O, negative 285.83. So those are all of my products. So I'm going to add those together, and I'm going to subtract off the same thing for the reactants. So I have 1 HNO3, so 1 times negative 173.22, plus 1 NaOH, which is negative 416.89. So this is what the equation should look like. You have to be very careful because we have a negative sign here, which if this sum over here is negative, it changes it into positive. So do what's in the parentheses first. Write out your steps. So I have negative 752.51 minus the sum of what's in these brackets, which is negative 590.11. So minus a minus would mean that we add these together and we get negative 162.40 kilojoules per mole. If you forget what unit's supposed to be on there, it is on the purple chart. Let's look at equation number, or the second one here. So we have C12H22O11, that is sucrose, plus O2 yields CO2 and water. So if we eat sugar, this is what is going on in our bodies. So we know that this is combustion. You can probably guess that it's going to be exothermic. So pause the video, look up the values, and then unpause it so you can check to see what you got. So with this, for sucrose, negative 2,225.47. Oxygen, we should have a little G beside there. I forgot to add that in. But that is in its standard state. When you look that up, it should be 0. CO2, negative 393.51. And H2O as a gas, negative 241.82. So now we have coefficients. Gets a little bit more tricky math-wise, but we just have to make sure that we write things out and be careful of signs. So again, products minus reactants, so if it helps to put that up there. So we had 12 CO2, so we take 12 times our value we looked up. So 12 times negative 393.51 plus 11 waters, so 11 times negative 241.82. Put those in brackets, and now I can subtract off the reactants. I have 1 sucrose, and I have 12 oxygens. So again, you don't have to write out every single step, but it helps if we write out what we get in the brackets. So negative 7,382.14 minus our value here, 12 times 0, well, that's 0. 1 times that is just this number. So negative 7,382.14 minus negative 2,225.47. That gives us negative 5,156.67 kilojoules per mole. So again, exothermic. So go ahead and complete the heat of formation worksheet.